All right, merging data. So again, we showed you a few examples of how to just create a data frame. So there is a function data.frame, or there's a function tibble, T-I-B-B-L. So even though we show you in this example data.frame, I would suggest using just the tibble function if you're just creating a data frame out of thin air. Most times you're not, right? But if you do happen to somehow, some way get like vectors into your memory that you're like, I need to make this back into a data frame so I know what to do, the tibble function will do that for you. And the reason I suggest tibble over data frame because again, the same way we said read_CSV has like better defaults. It doesn't try to guess factors and all that kind of stuff for you. Tibble doesn't do any of that stuff. Data frame will though. So, okay, we're just making like a super simple data set to illustrate an example of merging, right? So let's say we have a baseline data set. We have 10 IDs and they have ages from 55 to 60, right? So ID 1, the person's 50 years old. ID 2, the person's 55.5. All right, now these people came in for longitudinal follow-up, and they have some visit data, right? So again, we only have 8 observations. So again, 10 people came at baseline, only 8 people came to follow-up. There were 3 follow-up visits, and again, don't worry about the code that we're creating these, but just understand that we have baseline data for 10 people. That's the ID column. We have the age at baseline. And then the visit data, we have only 8 of them came for follow-up, and we have multiple visits per person. Okay? But only 8 came for follow-up, and then for each one of them, we have some sort of outcome. So, for any of those that not know SQL, this should be kind of a refresher of sorts, right? So there's different types of what they call joins. So in Stata, right, it's the merge command. In dplyr, it is a set of join commands. So if you do !join, it sees the different types of joining in R. And again, there is a cheat sheet for that. We will cover 4 of the most common. So an inner join. So you take in 2 data sets, and more or less, you can technically have the ability to join on different variables of X and Y. But I would suggest, before joining 2 data sets, figure out what column you want to join on. Usually it's ID or ID and visit, things like that, and name them the same thing in the 2 separate data sets, right? So what this is going to do by default is say, like, look at data set A or data set X, and look at data set Y, and what are the variables they have in common? And I'm going to join on those. And like we've said over and over again, R is case sensitive. So if you have a data set or you have a column in X called ID with all caps, and you have a column in Y that's ID lowercase, R sees those as different columns. So they have to be named the same thing, right? If you're like, I have 100 data sets and they're all called different things, and I want to do, you can do that with these, but again, at the end of the day, to make your life easier, just name them the same column. But if you don't put anything to join on, if you say X and Y, again, R is going to go through and say, what are the 2 columns that intersect? I want to join on all of those. That can be a good thing. That can be a bad thing. Because let's say you have 2 data sets, baseline and follow-up. In our example, we just had baseline where they have the ID and then baseline age. We had follow-up data where they had ID, visit number, and outcome. But let's say you collected their age at each visit. Now you have in your base data set, ID and age. Now let's say we collected age at visit, then R is going to go through and see ID, and it's also going to see age and try to merge them together. Well, no one stays the same age forever, so pretty much the age at the follow-up is going to be different than the age at baseline, but it's going to try to merge them anyway. So there is an argument called by, which tells explicitly which variables you want to merge upon. All right, now let's talk about the different types of joins. Inner join. So it only keeps rows that match for X and Y, both X and Y. You have to be in both X and both Y, right? It doesn't matter what order you put them in there. If ID, let's say we're joining on ID, if ID 8 or ID 9 is not in Y, even though it's in X, it's going to get dropped. It's just the intersection of all those things. This is very, very different than Stata, right? There's no one to many, there's no many to one, and there's no column that indicates merge 1, 2, and 3. Okay, so this is an inner join. You say keep everything that intersects between these 2. Okay, A full join is the opposite. Don't keep the intersection, keep everything. Keep like the union of everything. So if you have any data in X and any data in Y, you are going to keep it in the full join. Okay? Now, left and right joins, the order of the arguments really, really matters. So a left join says, so left means, so when you say left join X and Y, X is the left data set. Okay? So all the rows of X are kept, even if they don't merge with Y. Okay? Like for example, we're going to show you in a second. We have data for IDs 9 and 10 at baseline, but no follow-up. If we did a left join, IDs 9 and 10 stay there. If we did an inner join, they go away. Okay? Right join, exact same thing as an inner join. It just matters the order of the arguments in the sense like a right join is going to keep everything in Y, even if it's not in X. Right? So left join and right join are pretty much exactly the same function if you switch the arguments around.
So then for those, like the joint data set would, in the left join, whatever Y would have been data-wise, would just show up as NA or blank or something?
Yes. So here we're just doing inner join for baseline and visits, and if you do not specify what you are joining upon, you will get a little message from R saying like, hey, you didn't put anything in, this is what I'm joining on, just letting you know I found the intersection, it's ID. The dimensions is 24 by 4. Again, in the visits data set, there should be 24 observations for the 8 IDs. Now, if we look at the end of the inner join, we see it only goes up to ID 8 because, again, there is no follow-up data in the visits data set. Okay, so it's only IDs 1 to 8. Left join. So say we're keeping our, so if you're a Stata person, left join means the first data set is your master, right? And the second one is your using. If that doesn't make sense, if you're not a Stata person, don't worry about it. Left join means we're keeping everything in base, no matter what happens in visits. So again, it's going to tell us we're joining by ID. We have more observations here. Here we only had 24. Here we have 26. It's because now IDs 9 and 10 from the baseline data are kept because we said this is a left join. Base is the important one. We want to keep every single observation from that. And again, if there's no data in the visits, it comes up as NA. Now, if I do a right join, right? Again, we get 24 observations, and we look at that, we see we only have IDs 1 to 8. Now, it pretty much dropped IDs 9 and 10, because again, there's no data in the visits data set for 9 and 10. So the right join says visits is our master, and baseline is the using that we're trying to merge into. So it says we're going to drop anything that's not in visits, and 9 and 10 are not in the baseline. Or sorry, 9 and 10 are not in the visits data. Now, I will note that although I say it gives you the exact same output, it gives you the exact same data, but it's not necessarily sorted in the exact same way. Okay? So, although these are, like, if we switch the arguments, so that's pretty much what we're doing here. I said, so here, the big difference between this and this, RJ and RJ2, exact same function right join. I just switched the order of the arguments. Right? So before it was, here it was base and visits. Here it's visits and base, but again, it's a right join. But again, now base is our baseline data set, but is our master data set. We see there's 26 observations. It has 9 and 10, and so doing a right join is exactly the same thing as doing a left join, just switching the arguments around. I tend to only use left join for almost all the work I do. That makes more conceptual sense to me. That the first argument I put in is like the thing I really need to make sure every one of those rows is kept. Now, again, we use this function just to show you for illustrative purposes that they are identical after you sort the columns in a specific way, right? But that means the data is the same.
If you have some, like a database that's long and another one that's, for example, wide, would it figure it out when you join?
Depends on what that means. Figuring it, do you have a column that's, so like for example, if you,
So you have like an ID share between all of them.
it will merge them on ID. That might not be the resulting data set that you want, but it will merge them on ID, right? like for example, if you did what I said before, where you had a column of age in the baseline data and you tried to merge them in the inner join, you're going to get nothing because none of them match exactly. If you do the full join, it's doing a whole bunch of combinations of those joins. It'll have all the data right from the baseline and the follow-up, but things are going to be NAs all over the place. But yeah, it doesn't matter if the data is longitudinal or long or wide, as long as the variable you want merges in the way that you want it to. It's totally fine. It doesn't matter if the ID is repeated 100,000 times and only one line per person. Yeah. Hope that makes sense, right? So again, full join says keep anything if it's in X or Y. So here we're going to get that whole data set again because IDs 9 and 10 are in baseline, even though they're not in visit. So full join joins everything. All right. So inner join just keeps the intersection. Left or right join, you have one data set that is, in my opinion, like the way I think of it is more important. But it's not really more important, but it's just that you need to keep all the rows of this data set for sure. And then full join is going to keep anything in X or Y. Okay? So there's also some functions that people have asked kind of over the years, like, is there a function like duplicated? So there is a function, but it might not do exactly what you think it does. So duplicated 1 to 5 comes up false. None of them are duplicated. Now, duplicated 1 to 5, we add another 1 on there. We have 2 1s in that vector, right? So false, 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 false. True. So duplicated will give you true for any duplicated values after the first value. So what I mean by that is the first one over here, yes, there are multiple ones in this data set. But that does not mean duplicated gives you a true for both of them. So I don't know why it does that. I don't know the rationale for that being, if it were me, duplicated, this would come up true as well. But the idea is duplicated does exist. It'll tell you when things are duplicated, but only when the first one shows up, that is a duplication. So also, you can run unique on an entire data set, right? There is a function called distinct. In dplyr, it's almost, it's more or less the exact same thing as unique. Distinct. So let's say for some reason someone in your the data you got put in duplicated rows, exactly duplicated rows. Everything was exactly the same. And you're like, I want to get rid of those. So distinct or unique will just give you the unique or distinct rows. But again, that will give it must match exactly on all the columns. Okay. All right, so let's move on to lab 4. And then we'll kind of float around, maybe about 10 minutes for that, and we'll be merging together the crash and road data. The things that were wrong. Float around, I'll change it. No, I think the crash and road example is good. Yeah.
Yeah. We can. Yeah.
See how it's going, I guess. Because I think it's somewhere you had to do to get the grade, but I don't think that's the case here. Just to see that you know that 4 people respond to.
Yeah, but I mean, let's say day 2.
Okay, some class we have one day. So there's another other class that day, there's only 4 people respond.
You got other sheet stuff going on like 2 hours, 2.5 hours.
Yeah, plotting's fast.
It's a lot.
That's a lot. It's like
50 slides.
This is the last part of the lab, right?
That's probably a lot more fast. That's probably looks really slow, 5 or 6 slides.
Without functions.
No.
These stats is also kind of fast. Visual op, like it's just like this is how you do this. It's like
Yeah. That's true.
the data wrangling cheat sheet.
Oh, yeah.
This has a bunch of stuff. Yeah, I think page 2 has like the merging, doesn't it? Doesn't page 2 have the merging?
Yeah.
What is it?
Yeah, but like I thought they had an updated one.
I think you're right.
Data import.
It's that now, yeah.
Yeah.
Okay.
All right, so why don't we go over kind of part 4? So again, so if you just Google like RStudio cheat sheets, right? There's a whole bunch of them, and they're really, really good. They're really kind of things that in your office, just pin them up. Might not be a bad idea. So we have links to the data wrangling cheat sheet. There's a kind of a more updated one called the data transformation cheat sheet in dplyr. There's like a whole bunch of them. Data import, lubridate, per-r, string-r, right? How to work with dates, all that kind of stuff. This is the data transformation one, which has a lot of functions that we didn't necessarily cover, but I think they're really good, and it kind of gives you visually, some ideas on what kind of goes down when you're running some of these grouping and summarization functions. There are like arrange, mutate, the other options of like mutate at, things like that. So there are some other things that, so for example, pull is one we haven't covered. I think I said like extract in one of these examples, but pull will give it, so the difference is between that and select. You can select one column, you can use pull, but pull will give you an actual vector back, for example. It talks about distinct. I think it talks about, so that is not the separating and combining and the joining. So I don't know which one, I don't know what they have for that, but there's an older one called the data wrangling cheat sheet, which I think is really good, where it's talking about reshaping columns, and it shows you kind of visually where the colors go when you reshape things. It shows you joins in like kind of a visual way, which might be helpful if they're a little bit confusing, but definitely recommended. So I just googled the data wrangling cheat sheet. It should be a link in the lecture as well, but there are more updated sheets that they've given online. Alrighty. So now let's join the data and retain only complete data using an inner join. Those observations where it has both road lengths and districts merge without using the by argument, then merge using by equals quote road. Call the output merge. How many observations are there? So again, you should see that when we run this command merged equals inner join, we don't put any argument as to what we're joining upon. It will give us a heads up and let us know what it actually is joining on. But if we do explicitly tell it what do we want to join on, it won't give us any output. Again, if there are multiple columns, you would just collect them together and be like road and then like, you know, x2 or whatever. You just give it a vector of the column names that you are joining on. But again, it has to be characters. It can't just be like straight names like in unique quotes around. Okay. Oop. So again, there are 88 observations. If I table merged road, we see that Interstate 65, Interstate 70, US 36, and US 40 are in there. Again, I think it was Interstate 275 and US 52 are not in there because they either didn't have data on crashes or didn't have data on the lengths of the road. Make sense? All right, so only data in the output of merge was where you had road information on both those data sets. So let's join the data using full join, right? So this initial one only had 88. Let's join the data using full join and see that is 111. So now if I do a table of full road, I table that up. Let me just pull this up. The table full road. We see now that Interstate 275, which had a bunch of crash information but no road information, is still in there. US 52 is also in there, even though it didn't have any crashes. Okay? All right. Do a left join of the road and crash data set. Order definitely matters. How many observations do we have? So, if we do a left join of road and crash, everything in road is going to stay in there, even if it doesn't have any information to crash. So, does anybody know? All right, so tell me, what is the road that has road information but not crash information? So for example, there are other functions we haven't necessarily covered yet, or we're not going to cover. So there's intersect, there's set diff, so set differences, right? If I said road, crash, road, tells me, pretty much gets the unique values of both of them and gives me the set difference, but the order matters here. The set difference tells me that there is US 52 is in the road data set but not crash road. If If I switch up the order, it tells me Interstate 275 is in crash road, but not the road data set. Okay? There is another join that we're not going to cover called an anti-join. And instead of the intersection, it actually gives you the things that don't merge together. So if I say left join this, instead I say anti-join, shows me that US 52 is not in there. Again, the order matters with this function. So if I do the anti-join of road and crash, we see that this is the record in road that's not going to be that is not going to merge with anything in crash. Okay, that is the anti-join. And then alternatively, if we switch the order of the arguments around, we find these records in crash are not going to join with anything in road. Okay? So for the most part, you use anti-join just to do some diagnostics and see like what data is not going to get merged together. A lot of times that's not the data you care about per se, but you don't want that data dropped in many instances. So that is a helpful kind of function out there. So again, we see there's 89 observations. That's because it's the 88 roads that intersect with crash, but it is also included in US 52 where we have road information but no crashes. If we do the same thing, where we do a right join but we kept the same exact order, we see there's 110 observations because again, the left and right join, the order matters. So this is going to contain, because it's a right join, data from crash, but even if it doesn't have anything in road. All right? Does that make sense? So inner joins, everything intersects. Full joins is everything. Anti-joins and left, right joins, the order matters. Left and right, depending on which one is your master data set. And anti-joins will tell you what doesn't merge. Okay? Now, I will say there is a merge function in R. So it's not the worst, right? Not how I would just like blanket say that reshape is terrible, right? Reshape is okay, but it's not as explicit. I mean, you have these other joins that are much more explicit what you're doing. But it does still try to do too much, right? So it tries to merge, and there's different arguments in there if you do like to do left and right and stuff like that. But it's just a little bit confusing. Just use the explicit left, right, inner, or full joins. There are functions called rbind, cbind, which allow you to bind something via the columns or the rows of a data set. So rbind is the equivalent of appending in Stata or setting in SAS. Cbind allows you to add columns in addition to the previous ways you've done. For the most part, though, you should use these with a high level of caution, right? Because you better be sure whenever you're binding together is binding the right way, because it doesn't have the same level of checks that the joins do and stuff like that. Because if you want to add rows to a data set, you can usually just do that by a merge, by a join, right? By a full join with two data sets. And if things do merge, they'll merge together. And if they don't, they'll just append to the bottom in a full join, for example, if you have the same columns. But rbind and cbind will work, but again, you use them with a bit more caution. T can transpose the data, but not. No, it can transpose the data, but not recommended necessarily, unless you really need to do it. Right? Many times you don't want to make the columns and observations and observations in the columns, but sometimes you may want to do that. T will do that. It will transpose your data, but again, it usually will turn that into a matrix. So really briefly, we've already talked about is.na. Already kind of talked about selecting. So this kind of just introduced slice, but we've already kind of gone over that in previous lectures that we've introduced earlier. So pretty much using the one and n function in slicing to get the first and last observations from a data set. So we're just going to go over that and move on to visualization. We do have some extra slides in here and in a lot of the lectures that we don't cover. Usually that is because they are stuff from base R that just might be helpful if you're saying like someone knows how to do it this way, like what is kind of the equivalent. But for the most part, we don't think that's worthwhile to teach, but we do give them to you in case you're interested. All right. Now this should be the interesting, really exciting stuff, fun stuff. Data visualization. All right. Any questions before I move on joining, separating, uniting, all that kind of stuff? All right. So we're going to be using some of that mortality data that we had before. Again, we just want to show you the first couple of observations. We read it in, and the first column is just going to be called X1. It's the country, and every other column after that is the mortality estimates for children over all the time we had observations. So again, you could just use the function read_mortality if your internet's not working or you just don't feel like downloading that data set if you're trying to follow along. All right. So the data are quote-unquote not tidy. So they're not tidy in the sense that every row is not really an observation. We have multiple columns of different years. What we want to do is have a column from year, a column from mortality, and then we can filter out any of the years that are missing. That's at the end of the day what we want to do. So here, all we're doing is we've already renamed the data. The first column to be country, right? We've already showed you how to do renaming. So we took the data set. The key that we are going to create is called year. The value we are going to create, the column we are going to create called deaths, and we are going to gather every single column up that exists in this data set except for the country data set. Or sorry, the country column. So again, take all the columns of the country, make them rows. So we're doing here. So now you should note country, character, deaths, double, so it's a numeric. But year, although you see it and you're like, oh, those are years, it is going to make it into a character. Now, that is almost, I believe, every single time you do a gathering operation, you're gathering column names to rows. R is not going to make the numbers for you. You have to do it yourself. Because the idea is most times column names are not using numbers. In this case, they are. So it's going to turn it into it's always going to bring it as a character. And if you want to actually plot them the way they should be plotted as numerics, we're just going to mutate and replace it using as.numeric. All right. So now we got a quote-unquote tidy data set. So for each country and year are unique combinations, and then we have the mortality data. And again, we are filtering out wherever there is missing mortality data because not all countries kept records for that long. All right, quick plot. I've already showed you ggplot. So we are just grabbing Sweden in this example. So we're saying filter country equals Sweden. We're using ggplot, which we've shown before. I want the x-axis to be year, y-axis to be deaths, which are columns in my data set, and I got to tell it what data set I want. Now, this is the default plot. Again, if you put an x and y in ggplot, this is a scatter plot. Okay, simple stuff like that. So, some other arguments that you can add into ggplot. So let's say, we're looking here. So we see it goes from like 1760 out to 2100. Right, so these are projections for child mortality in the future. So you say, you know what? I don't want projections. I want only the quote-unquote real data. So you can put an argument xlim, which stands for the limits of x, the limits of the x-axis. We put in the vector. So it's always two numbers, the min and the max. So 1760 up to 2012, and it's the exact same plot, except now the x-axis only goes up to 2012. So, now, we've shown you ggplot, and it stands for quick plot. But that is not the main function in ggplot. The main function in ggplot2 is the ggplot function. So that is the constructor, the thing that allows you to construct really complex plots. So the syntax is this. ggplot, what is the data set, and then what they call a mapping or the aesthetics. Okay? So this is a little bit different. This is why we kind of introduced ggplot a little bit at first and then introduce this a little bit later. So always give it what data set you're going to put in there, right? You always have to work in a data frame just like dplyr. It should be totally straightforward. Now, the only big thing about ggplot2 is that when you're mapping variables to some sort of aesthetics, so being the x-axis, the y-axis, the size of the points, the shape of the points, the opacity of the points, if you want them high or low, the color of the points, the fill of like a histogram, any of those kind of aesthetics.
you wrap it around this function AES. Okay? So again, here we're saying ggplot, we're creating a blank canvas with this data set. This is going to be our x-axis. This is going to be our y-axis. That is all we've told ggplot2 to do so far. Unlike qplot, ggplot2 does not make any assumptions about what you want to make. Qplot says you gave me 2 variables, you want to do a scatter plot. This just makes an empty blank canvas.
So let me just show you that, like, data viz. So if I run g equals, so I'm going to run everything up until this point, and I'm just going to show you the output of g. Also, note, this is going to be a little different. Every single time we've done qplot in the past, we've pretty much said, like, just print it out. Now, I have not done anything. I have just made a plot, right? So if I run this and assign it, where did that go? So remember when you just put x, you just write x and it prints it out, right? That's the default behavior in all. Similarly with plots, similarly with ggplot, you make a plot, it says, hey, print it out. And printing a plot is to actually show you the plot. Now, differences here, we assign the plot to some sort of output. When you say x equals 5, it doesn't print anything. In the same way with plots. So I've assigned g to this output. It doesn't actually plot until I print it out itself. But note, nothing's there. That's because the ggplot function just lays out your aesthetics and then you add layers on top of them. That's the idea of the grammar of graphics. So you've set up what data it is and maybe some aesthetics, but in order to get things to show up, you have to add layers, like a point layer. One of those layers is like, okay, add points. So what if you're like, I want to add points and lines? You just add them together, right? Now, I will say there are some little differences. Let me zoom this out a little bit. There are, order for the most part doesn't always matter, but sometimes it can. So this is literally telling ggplot2 to make this blank canvas, add the points, which are colored black, and then add on a line, that is green. Okay? That is literally what it's telling it. But if I switch the order around, looks a little bit different. It's because the order in which they were plotted is a little bit different, right? It plotted a green line, and then it plotted black points on top of it. So let's just briefly look at the difference between this and this. They're slightly different because of the order in which they were plotted. Okay? So just note, for the most part, when you're using this ggplot2 function, order doesn't really always really matter, but sometimes it can because of the layers you're actually putting on top of each other. So again, ggplot2 is this generic function, and then you literally add things to it to make the plot. Okay?
So if you have 2 different ggplot functions that you're working with at the same time, and you name them different things, like one's g, one's h, and then you add layers on top of each, do the arguments automatically know what you're referring to, or do you need to start specifying it in the parentheses?
I don't understand what you mean. So do you mean if you have 2 different plots, you
Yeah.
can't. So at least there are ways to combine 2 ggplots.
Okay.
For the most part, I will say, to starting out, that is not recommended.
Okay.
It is not recommended because almost all the things you want to do, like, oh, I want to plot this one and this one as 2 separate plots. There are things for that, but like facets, and they do smart things to make sure like the y-axis and the x-axis are exactly the same for those panels. But there is a way to create an entire ggplot and an entire different ggplot with maybe an entirely different data set and combine them together. That's a little bit more advanced, and it's also a little bit more dangerous because you can get misleading visualizations and misleading things by doing it. So it might be, hopefully it's a little clearer after we go over like facets and stuff like that. Was there a question in the back? No? Okay. So common aesthetics. X and Y variables. So for example, not every single function takes an X and a Y. Right? Histogram's only taking an X, for example. right? You don't need another y variable to plot it. Color, right? You want to color things by a different variable. Size, you want the size of a line or the size of points to be different. Fill's a little bit different than color. If you think of a histogram, there are lines that essentially make the bars, and then there's color inside the bars. So color will change the color of the lines. Fill will actually fill inside the polygons or whatever. The shape you can also map to a variable, right? You want diamonds or squares or circles or circles with empty holes or something like that for a different variable. You can do that. So if you set these inside AES, in the AES function, you set them to a variable. If you set these properties outside of the AES function, it will set them exactly as they are. So what I mean by that is, when I showed you this function right here, I didn't want to color by a variable. I just said make the color green. Okay? Here. That is very different than this. It does not do the same thing. When you put something in AES, it assumes you're using variables from a data set. So what this is doing actually in the background, it's saying color equals green. It's saying this is, inherently in the background, it's kind of like making another column in the data set and then mapping it to that column, which doesn't make much sense. So when you're trying to set something exactly like you normally would, you're like, I just want to change the color to be green, right? You don't use AES. But when you're mapping to any variable, you do. Now, hopefully, yeah. To the plot, yeah.
So before you originally plotted it on line 2, before you added color.
Yep.
It was black.
Yes.
But then when you added AES, it still became a red line.
I only added AES for the line.
Right.
I didn't add it to the point.
Why wouldn't so you're labeling the line as a variable?
I'm mapping the color of the line to a variable.
But how come the color didn't stay black?
Yeah, why did it change to
Why
red?
did it change to red?
Because there are different defaults for when you map colors.
Oh, because
To a
it's saying
variable.
it didn't map correctly, so it's coming up red.
Well, that red-ish color is the default first color in the palette. So pretty much when you start mapping to colors, there's like a default palette that says like color 1 is this reddish thing, color 2 is this greenish thing, color 3 is this blue thing. You can change all those things that you want, but it has some sort of default that it says like color, like some set of rainbow colors that it goes through. So there is a difference between this. So let me just say head Swede. So this data set doesn't have really much, but let's make a column in 2000, so greater than 2000. Okay, something like that. Something very, very simple. And let's do gr 2000. I have to remake the plot because the data has changed, so I have to remake the plot. So, for example, let's zoom this in. The color is mapped to like a reddish thing and a bluish thing based on these different levels of this variable. That might be hard to see in the back, so like pretty much blue for greater than 2000. That is not to say, so that is different. So you can exchange, so we will talk about this. I will go back to the slides in a minute, but there is a way so the difference between those two, I'll pull it up on the side. The difference between those two sets of functions I ran, or the sets of code I ran, I said ggplot, right? I want x to be year, y to be depth, and color to be greater than 2000, true or false. Now, if I set it in the ggplot2
function. It globally sets that for that entire plot. So any kind of like in some respects, if you group the data, any function you use after that is going to assume that you want to perform those functions on a group. Similarly with ggplot, when you set the aesthetics, when you create just a blank canvas, anything after that is going to assume that kind of mapping. In the sense that now when you say add points, add lines, it says, okay, X is year, Y is des, and you want the points or the line to be colored by this other variable. So that's why this looks different than the other two. And the take-home message here, if I make it, the take-home message here is that you can make global changes to your plot, or you can make changes to specific things you add to the plot. Again, these are called geoms, geometries, right? Lines, points, histograms, box plots. So if you just say like in your command window, say type geom and hit tab. There are a lot of different geoms: bar, area plots, box plots, density plots, error bars, hex plots, histograms, right? Lines, maps, points, QQ plots, ribbons, smoothers, all that kind of stuff. We will go through a few of them. All right. So here's the thing. If you're like, this makes no sense at all, qplot still can get a lot of your needs done to start out. So if you're like going back and you're like, I want to plot stuff, and now I'm not doing anything because ggplot's like super confusing, stay with qplot. But a lot of the things, so the nice thing about qplot, it gives you back a valid ggplot2 object. So if you want to add things to it, like we're going to show in a minute, like I want to add the x-axis is this, the y-axis is this, that's totally fine if you make the plot from the get-go with qplot. Okay? Just don't be alarmed when you see a lot of answers online that start with ggplot. Okay? Because a lot of times, again, like I said before, you say x is year, y is deaths, and then let's say you are going to color by another variable, right? Like what we just did. qplot, you don't have that fine-tuning where you say, like, this one's colored by this one's colored by this, and so forth. So qplot is a little bit more low. But anyway, if you're like, I'm comfortable with qplot, not comfortable with ggplot, it's fine, just keep with that for now. So again, you can assign the output to q. So this is the fact that you can assign a plot to a variable is a very, very special thing, because then you can make a lot of plots with just changing out variables or changing a lot of specific things. Again, I don't know anyone who has ran an analysis once. I don't know anyone who's made only one plot, right, for a specific type of figure. Right? It's always like, let's change the colors to this and this, and like 2 weeks later, it's like, let's change them back to exactly they were like a month ago. And so that's why creating a object and being able to just add things to it is really, really, really useful. So G on its own can't be plotted. It can, but it'll just be a blank canvas, right? G was the output of just the ggplot command. We need to add some layers or geoms. Again, these are probably the most common ones that I would use. So geom points add points, lines, density adds a density plot. Again, the like a smooth histogram. Geom histogram. I really wish that they made a geom_hist. They do not. I always forget it's a fully histogram, right? But if you want to create a histogram, that's the one for you. Geom smooth adds a smoother through the data. So like a low S smoother or a generalized additive model. This is hugely useful for the things you want to do. So obviously you want to fit a line to data, but many times you want to fit a smoother through it to see if the data is somewhat linear before you do a linear regression. Geom box plots, geom bar for bar plots, geom tile for like rectangles or heat maps. Okay, so those are the standard kind of ones we're going to go over briefly here. All right, so again, you add things to the plot with literally a plus symbol. It is not the pipe, it is plus. So we're saying G plus geom point, and then we actually print out the G points object. So now G is still hanging around, right, in your memory. G is still a blank canvas. You can add lines to it, plot points, whatever. G points is now its own individual object, and then when you ever say print or just write it out, or if you just write G points, it'll print it out to your screen. And that's the way you can add points to a plot, which we've already kind of shown. If we say G plus geom line, instead we wanted a line point, or we wanted lines instead of points. Right, we've already defined the canvas, we're just adding a layer on top of it. And again, if you add both of them, that's what you get. Geom smooth. So we added a line plot plus a smoother. So this is, depending on the number of points, either a low S smoother, so a local regression kind of average. So you can think of it for the most part as doing a moving window. So it takes a window of points, does a linear regression to get like a slope of a line, and then moves it and moves it and moves it, and that's the shape of the smoother that you're using. So usually there's a window and some sort of function that collapses the data. Either it's taking just the average of the data, or it's taking some local regression. So that is what a smoother is doing by default. There are other smoothers you can do. You can do, for example, if you say the smoother is the LM function, it'll give you a linear fit. If you have like a lot of data, like thousands or millions of points, it'll do a generalized additive model in the background to give you the smooth estimate out. Low S is really good. It's like a non-parametric smoother. It's great with small data, not so great with big data. All right. So let's say we want to plot the full data set, right? We don't want to plot just Sweden anymore. We want to take the long data set, we want to filter the country to be the United States, United Kingdom, Sweden, Afghanistan, and Rwanda. So now we got a subset of our data that we feel like plotting, right? And now we're going to take that data set, pipe it into ggplot, right? Because again, the first argument is usually the data. And we say X is here, Y is this, and now we're going to color by country, okay? And then we are just going to add in a line plot, right? So here, this is kind of the default output, right? So the variable name is in the legend, different colors based on the default palette, and it shows you what each country is separately. Okay, so again, the x-axis is year, the y-axis is the number of deaths. Certain countries didn't have data until later, so they don't have any lines until a certain time point. Yeah.
Could you, I'm sorry, I know this is possibly you already went over before. Why do you have long? Sub equals long, filter.
So that is the data set with all the that's the data with all the with all the countries and all the years.
Why not just have a filter though? Why not just like immediately filter? Why not? Why does the long have to be there? Oh, that is the data set. Oh.
Yeah. So either we're piping or just say filter long. Either way. Yeah. It's just a choice. Yeah. So we're just either filter long or pipe it in. So again, we're doing a subset because if we were to do all the countries, it would be a very, very, very messy spaghetti plot because there's a lot of countries in this data set. So now we got, okay, so now we have the line where you say, you know what, I don't love that Rwanda is yellow. It's not my favorite, it's not the color palette I want. There is a bunch of different functions. So any aesthetic you can think of, right? There is a scale function for that. Scale fill, scale color, scale shape, right? In this case, we're going to be using scale color, and we're going to manually add the colors. So how can you normally, so let's just look at all the scales. So if I say scale underscore, right? Scale alpha. Alpha stands for the opacity of a point. So you want something to be, you know, lighter or actually show through with some opacity, right? Scale color. Scale color is spelled the other way. Scale discrete, scale fill, scale line type, right? So these allow you to define how the mapping is done with some sort of value. So let's say, for example, you want the United States to be blue, United Kingdom to be green, Sweden to be black, Afghanistan to be red, and Rwanda to be orange. Scale color manual will allow you to manually set the values. A lot of people are like, yeah, that's how I always would want to do it. I always want to manually set my values. Sometimes you want to use a palette, right? You want to say like, oh, like this is like kind of like a continuous measure. I want to scale the data by, you know, everything going from red to blue or red to green or something like that. So there are other scale functions. So if you say scale color brewer, right? There is a set of really good palettes that are good for sequential, diverging, or qualitative color scales based on this thing called Color Brewer. And if you go to Color Brewer 2, it shows you how different schemes look, and it tells you the name of that palette. So these are a bunch of different palettes for sequential data, going from like blue to red and stuff like that, and then qualitative. So all I'm saying is scale every single thing you're going to map to, whether it be line type or color or whatever. There's a scale something, scale color or whatever, scale fill, and then there is always one of them that says scale blank manual. That allows you to manually set the things if you want to. In this case, we're manually setting each one of the colors to the color that we want it to be.
So you don't put the colors in the geom line, right?
No.
Right.
It's like a different. I think you might be able to do that, but I usually just add the line and change the aesthetics later. Yes.
If you're manually setting colors, can you manually set to a specific hex code?
Yeah.
Or do you need to pull it up?
You don't actually have to say color. You can say whatever, like hashtag FFFF or whatever. Yeah. Now some of these recommendations are going to be like my personal preferences. So take some of them with a grain of salt. But like I've been taught like legends should never be outside of the plot. That doesn't make any sense, right? They should be inside of the plot, or you can actually there's a function called there's a package called ggplot, right, which will allow you to just put the labels really close to like a certain one, the actual data themselves. But a lot of times, or at least one of my big gripes with ggplot 2, at least the defaults with legends, is like it scrunches like the data up and gives you like this really big legend over here, which is totally fine. But sometimes you're like, you know what? I just want to visualize the data. I don't necessarily need to see what country's which. I just want to see overall shapes. So there's another function called guides. Right? Guides is the function for all the legends. And guides has an argument for every single type of the setting. Alpha, line type, scale, fill, color, all that kind of stuff. And then you just say guides, whatever that aesthetic is, equals false, will remove that legend from the plot. Because sometimes maybe you've added annotations in there yourself and you don't need that whole legend. So now you should see at least like these are printed to be the same size. So like this much is now data versus before, like this much is data and this much is legend. All right, so again, let's go to part 1, but qplot is totally fine to start out. If you're saying like all this makes no sense, come back to this after you've kind of mastered qplot to show how to do some of the very kind of fine-tuning things of the data. And I will say this, that it is for new users, I understand there is a lot of frustration a lot of times because people say like, I just want to make that point like green, and it's like hard. And I understand that. That's why we definitely show you the manual way to do it, the manual coloring scheme, because that should at least do what you need it to do. But I do understand and acknowledge that there is a lot of frustration. They're just like, I should be able to do that. And you're like, you can. It's just not always as intuitive as you maybe like. I don't know how many there are. Sorry, 54 more slides. No. After that space bar. We're up to slide 74. Take more work.
many slides are in statistics?
We could also just go through the slides and do that again. 22 parts of stats.
Excuse me?
22 parts of stats. Slides.
Wait, where's part 2?
Plots.
Yeah, we only just say part 1. Go back into visualization lab. So just do questions 1 and 2. Sorry about that. Part 2 should be in there. That's what I'm saying. I already, yeah. So should I, if you want to,
Yeah, I did. So. And then all this in the same layer, I say that. Okay, so. Thank you. Great, just set how. That's what I'm. It's okay. The bottom is just like stuck. It's not fun to.
they represent the different bus lines. The different bus lines and yeah.
So these steps are actually doing set numbers is. Okay. So I need to just. Steps.
Yeah.
Okay, so where do I add that? Oh, so I'm doing after I'm gonna put color.
So that's a good question. So you actually it's a function. So you should plus excellent.
Okay. Well, I'm not using a palette, so color equals scale.
Then it would just be like a variable you bought.
Oh, okay. So it's
You need to see if that works. Just try that.
no quotes.
Okay. The reason for that is
If you just
that
plot
you
this
have
out,
the
then
x-axis
you
and y.
can just make sure that you plot.
So you actually have to get it color.
Mhm.
Does make sense?
Yeah, I just wanna
So
understand
like in that
where
case,
I'm
it was just like
or even if it's like
this
visual.
right? So if you want to limit the x-axis,
Okay.
it is
Awesome.
It's the cues like in the sense, you want these garbage, you're like asking
So,
it
in these steps, I just wanna make sure that we have this, you need to say
so it can understand.
kind of what you're gonna add,
Yeah.
and then you add it later, but you need to
So it's
describe
like plus
what
x
you're
Yeah.
adding in a step.
Exactly.
Oh, that's good.
y
It's like
and a.
Yeah,
as a.
yeah.
I think
Again, like nothing in like,
if you type y and a
set, right, so like what sorry, color
Yeah, so the syntax was right, it just
Yeah.
wasn't actually matching up with
Yeah, you should
anything
have
in
like
your
a color
syntax.
as.
do like
Okay.
So, like, you're not typing color.
Yeah.
Just use the default.
11.
So I guess if I have the color here for the line, and I wanted to just like go through the phrase and like change the background color, so do I need to prime those other color changes
Yeah, so
instead
the
of.
background color is like gray and stuff. So
Okay,
usually like the themes, he'll talk about themes.
okay, alright, thanks.
Makes sense? All right, so we're going to go over the first question, and I'm going to point on some couple things a couple students have said. So we're going to run everything up until this point. The average ridership we're using the AVG average data set. So I'm just running everything up in there. It pretty much just read in just the data. So we see the date is an actual date column. We have the daily ridership, and then we have each different line, the type of data it is, and again, all these are just averages because that's what we've kind of subset this to be. So now, using ggplot, we can use X is the date, Y is the number of people, and then the data, and we get a scatter plot like that. But again, this is over multiple lines. This is the orange, green, purple line all together and smashed in one plot. There was a question on how to do like xlims in ggplot. So xlim is an actual function. So if I call this q, if I say q plus xlim, that's the ggplot way of adding x limits. So now, the data we showed in the lecture, the x-axis was like numbers, 2010 to 2012, right? They were just years. Here, what is the x-axis? What is the type of data? Date. So if we want to limit the data by dates, we have to pass in dates like 05, 03, 2012, 06, 04. So we want to do X limits. So I should have printed that out. We're going to do what? Oh, sorry, I didn't run that first. That now it shows us only those dates that we care about. But pretty much if you're putting X limits or Y limits or whatever you're doing, you have to make sure that you're passing the same kind of type if it's a date or just if it's a number. So the xlim is a function that you can add to a plot. Color the points by the route. So orange, purple, green, and banner. So again, using ggplot, we can just add in the color whatever spelling you like, and the column name of line. And now we see that the line is, so the data is colored by each line what it is. Again, it's a scatter plot. Again, it gives you some default palette that we're going to change in a minute. Right? I'm going to save this output out of something because we're going to add to it later. So I'm just going to call it first plot. So we have the colors, all that fun stuff. So add black smooth curves for each line. So here I'm going to do a little bit of combination of geom, so of ggplot and geom smooth, of like the ggplot way. So here we just created the ggplot like we did before. I add geom underscore smooth. I want to group the data by the line, but I want it to be black. So let me show you the differences between these two. If I just said add geom smooth. If I just add geom smooth, totally fine. What it will do is if you might have to zoom in a little bit. Let me just put it up over here. So again, by the way, it'll give you some sort, if you don't tell the method of smoothing that you want to do, it'll give you a little message that says like you use the generalized additive model to create some sort of smoother. Now, what it does is it colors it by line. So if you see in here, you actually see a line that's separately colored for each individual bus line. Okay, and you see a little standard error bar around that. But I wouldn't always trust those standard error bars because this data isn't independent, right? So those error bars are probably too small. So here I can again add on a geom smoother. I want there's another aesthetic called group, which will allow you to calculate statistics or run things over each group individually. So you need that if the data isn't grouped already. If you've already grouped the data by color, for example, then it will do that by color. But if you just pass in geom smoother and say, I don't want things to be grouped by, I don't want things to be colored in a certain way. Sorry, that wasn't clear. The group aesthetic allows you to do things over individual groups by a variable, and sometimes you want to reset that if you've already kind of grouped the data by color or something like that. And so we add the geom smoother. We wanted to do a smoother for each bus line separately, and we wanted the color to be black. Okay, because that's a lot easier to see than the last one. And also, if you look in the geom smooth function, there is a whole bunch of, I would highly recommend looking at this. There's an argument called SE, which stands for standard error. If you don't want those confidence intervals or whatever around them, you just set that equal to false. So yeah.
So since you named it first plot earlier, can you just go first plot plus genome smooth and drop off?
Yep. So I could have also just said color, I believe color equals black, but I'm not sure that that'll do it. Yeah. So if you just say color equals black, it resets the grouping, right? Because it was grouped by color before, and you're saying, you know what? Throw away the grouping before. Now just call it to be black. So now it gives you a smoother, but that is not a smoother by each bus line. It is just a smoother for the entire data set. So you can just say group it by line. So that's why we needed to do these things, because we wanted to set the color to be something different, but the color was already set to be something. So we overrode that, but we still wanted the statistics, the grouping, to be ran over each individual bus line separately. That's why we had to do those two things. So color points by the day of the week. Again, do the same thing where we change the argument for what we're setting to be the color. So sometimes it can get a little bit annoying with our studio. Right? If we look at this data, it's kind of all jumbled together. But again, this is multiple bus lines, but this is different days of the week. And again, it uses the default palette, which we're going to change in a second. All right, let's replot 1A, where the colors of the points are the name of the line, right? So banner should equal blue. We said palette equals blue, dark green, orange, and purple. Again, we can take this data set and we will add in scale color values equals palette. So we tell it what the palette is, what the color should be. Now, in the example in the slides, I said like value United States equals blue, like Sweden equals whatever color, right? That is probably the best and clearest and safest way to manually label the colors. If you do not do that, if you just tell it a color palette, it will do a few things. One, if the data is a factor, you give it the color in the order of the factor, right? In this case, we didn't make it a factor yet. Maybe we should have, but we didn't. So, if you just pass in the color palette, again, in the background, it's going to make it a factor, right? So what is that going to be? That's going to be an alphanumeric. So in this case, it is going to be banner, green, orange, purple. So if you know the order in which it is, that it's fine to put it in like this. But again, to be safer, you probably want to put it, either make it a factor so that you actually know that, or set the names of this vector where like banner is this, green equals this, orange equals this, purple equals this. And then if you do it that way, it doesn't matter what order you put them in. I can put them in any order I feel like, as long as I don't mess up the code. And then if I put it in there, we should see if I can spell orange correctly. It should put the line in as the correct color if you put some names onto this vector. So again, that's the probably safest way to do things like that. But again, if you know the order, you can just give it the palette itself. All right. So box plots, kind of going over these a bit. So ggplot, we're just gathering that X is a year, Y is deaths, and we say geom box plot, and we get this really uninformative box plot here. Right? Again, that is because ggplot, what it does is it handles things differently if values are numeric or if they're character slash factors. Right? You can think of as a logical data set as like trues and falses. You can think of them essentially as factors. Right? So it treats numerics different than everything else. So here, saying the x-axis is year, the y-axis is death. So I want to do a box plot. Let's say like, yeah, well that's like some continuous measure. It's like, that's probably not what we want to do. So what could we do? Let's make it a factor. Great, right? Sorry, did I make it? I should have made it. Yeah. So we make it into a factor. Now, what is the downside of making that thing into a factor? The years went from like 1760 up to like 2100, right? Not great, because it made a factor for like 2100 to be all the way out here, right? It just puts things in order. So it's nice. The factor argument
making this thing into a factor made it so it did a box plot for each individual year, which we wanted. But the bad thing about that is it didn't, in fact, keep the x-axis to be true to what it should be. It also makes this like heinous, like factor year to be like every single point is plotted. So sometimes, and I would say a decent amount of time, you want to do something like this where you have a continuous x level and you still want to do box plots for each individual level. So that's where this group function comes in again. So here, the year is correct in the sense that these are projections, so they are in the right thing, but we wanted a box plot for each individual year. So we can define both the x-axis is 0 and also tell it that we want that the data to be grouped by that. I do not believe if you group the data by year and then run this, it will. I'm just saying I don't think the group by changes anything. I'm not 100% sure on that. But all I'm saying is if you wanted to do something by group and if you start getting stuff like this, you might want to look into group, right? The group aesthetic. Geom jitter is one other thing we're going to talk about that allows you to jitter the points. So a lot of times when you're plotting box plots, you might want to actually see the data behind it. There are a whole bunch of other geoms out there, a whole bunch of other packages. So like violin plots, volcano plots, like all these other types of plots that people have written packages on top of. Geom jitter allows you to jitter the points a bit. So here we're just grabbing the data for years 1995 and less than equal to 2000. Again, we're doing the same thing. We're taking this data set, we're making year into a factor because in this sense we know we just have 5 years. We could have used group again. Y is the death column, right? We're doing a geom box plot, outlier shape equals NA. So every time you make a box and whisker plot, pretty much it puts points outside of 1.5 times the QR. It's higher or lower, it puts points, right? See these dots out here? It says like these are quote unquote outliers, right? Shouldn't be called that, they're just outside kind of the range of this rule, right? That's what they are. But they're kind of denoted as outliers in box plots, so that's the terminology we're going to use. But if you're going to plot the points yourself, which is what we're going to do, tell it, I don't want those points. So we said the shape is missing, which will mean it will not plot those little points. It'll just give me the box and whiskers, right? It won't give me the outlier points. So the reason we want to do that says don't show the outliers because we're going to do that ourselves. So geom jitter will actually plot the points on top of everything. It's kind of like geom point, but the thing is, if I plot a point, every single person every single record with 1996 is just going to be one column of things. So we want to jitter them in some direction. So here we're saying jitter, but jitter the height 0. We don't want to add noise. So jittering just means adding noise to the data. So we want to add noise in the x direction, not the y direction, because we want to keep the depths to be exactly the height they are, but we want to jitter them around so we can see where the distribution really lies, right? Okay. Facets. Facets are the things you probably have been looking for. Facets allow you to do the same plot with multiple panels in a smart way that keeps the axes the same if you want them to and lines them up in some logical fashion. So here we are taking the data set, piping it into the ggplot function again, doing the exact same plot with those 5 countries. We're adding a line plot, and then we're adding this new function called facet_wrap. So facets, again, make multiple panels. And the way you give that syntax is this formula syntax. So it's something tilde a variable. Okay? So we're saying add lines, and then we want a separate plot per country, right? If we had multiple, that doesn't mean there's always one line per panel, but the idea is we want separate panels on this variable. Okay? That's what facets are. So there are other arguments to put in facet wrap. So before I go on to this really quickly, note it has one axis over here. This one doesn't have an axis. This one doesn't have an axis because by default it enforces all these to have the exact same axis for comparability across and comparability down. You should know that this doesn't have an axis. This doesn't have an axis because they are the same axis as here. So everything should be pretty comparable. You're not duplicating plots. I will say, to do things like this, and the smoother we showed in the last plot in base R is like 20 to 40 lines of code. This, very succinct, very simple, pretty much straightforward. So again, there are other arguments that if you're like, I don't want the x-axis to stay the same, there's an argument that can change
So one of the other important arguments is the number. You can tell number of columns or number of rows. Let's say like I don't care about things looking like this. I want them to be all lined up. So I say I only want one column of data, and so we can see the trajectory of each one of these things where the x-axis has stayed aligned and they stack them on top of each other. You could say n-col equals, 5 or 6, or n-row equals 1, and it'll show it row-wise. So in ggplot, the argument you're looking for here is facets. Again, it's the same syntax. You have to use the tilde, which should be right where the backtick is, but not holding shift. So the idea is you put facets for each country in the ggplot, and it does the same exact output as facet wrap. So it doesn't, in formula syntax, which Andrew will talk about in a minute, with respect to formulas, you can add multiple arguments, multiple variables. So if you want it to be by country, some other x variable, some other x variable, some other x variable, you just add them together. Like you can think of them as I want to do these plots as a function of these other variables, as a function of x1 and x2 and x3, and it does different plots for those. We are going to move forward a bit and then go to the lab because we are running a bit slow on time, and some of these slides aren't necessarily going to confuse you for the next part. So devices. Knitr is great. R Markdown is great. You make a plot, it's embedded in there. You don't have to worry about saving that plot to somewhere. It's embedded in your machine, right? But sometimes, or most times, people are like, well, I don't want just this plot. I want to be able to save it. I want to save it in like 600 pixel resolution, or like 600 pixels per inch, all that kind of stuff. That's where devices come in. By default, it's going to show you a little plot in that little panel in your RStudio session. You can technically export a PNG and things from that. I wouldn't recommend that. I would recommend always doing it in code, right? And the functions to do that are bitmap or BMP, JPEG, PNG, TIFF, and PDF. Okay? All of them have very similar syntax in the sense that you do this. You open a device. So you use one of these functions, you give it the file name and some other options. Height, width, resolution, all that kind of stuff. So open a device. You print out some plots. You plot 1, plot 2, plot 3, plot 4, plot 5, whatever. And you turn them off. Dev.off is how you end all of it. You shut down all those devices. So the way R sees it, you open a device and you're pumping out like pixel information to that device, and then you turn it off. Now, PDF is the only device for plotting that allows you to do multiple ones, right? A PNG is just one plot. A JPEG is just one plot. A TIFF is just one plot. PDF, you can have like multiple plots. Now, if you do open a PNG, for example, and you do plot 1 and plot 2, what that will save is just plot 2. Whatever the last plot you plotted when the device was open. Okay? We don't get into this from the get-go because if you leave a device open and then your code errors or shuts down or like something goes wrong, that device will, I mean, not if you close R, that device will be done. But in order for you to be able to view it on your computer, you have to turn it off. So you have to open a device, make the plot, and then dev.off to turn it off for you to be able to actually view it on your computer, because otherwise it is not a closed device to R. It's still dumping information in there. You can't usually read it on your machine. So if you do this with a PDF and you try to open it and you haven't turned it off, and be like, this file is corrupt. And you're like, what happened? Almost always you haven't turned off the device. Okay? Yes?
You have to type in dev.on, or can you go straight to PDF?
Just PDF. So all those pretty much is implicitly saying, I'm opening a device, and this is the device I'm doing it, just one of these types. Okay? Makes sense. So most of the time I use like PNGs, so I say like PNG, whatever, height, width to be something in inches, I give it like a 600 pixel resolution, and then I do a dev.off or like a TIFF. So this is really, really useful because in other systems sometimes it's kind of hard to get some journal editor like a 600 pixel resolution TIFF that is like publication ready. All right, labels and such, kind of making, so the reason I said some people don't like ggplot 2 in some respects is it gives you something that looks nice enough, but not nice, right? So nice enough means like, oh yeah, like look, it's great. Like no, like you need to make that better if you're giving it to a report or a publication, and there's a lot of work that still needs to be done, but ggplot 2 sometimes gives you this false sense of security, like I made a beautiful plot. It's like, you made an okay plot. Make it better, right? So usually you got to do that with some of these things we're going to talk about right now. So labs, so labels. So the functions, we already talked about xlim, there's a ylim, there's an xlab and ylab. So that allows you to label your data, label the axes, right? Deaths per 100,000, we're going to give the Y lab over there. Maybe we want year of collection to be the X lab, right? So we put our labels on there by literally adding them like we would any other geometry or any other thing in ggplot. ggplot also has a title function, right? If you want to put it at the top, it's called ggtitle. The reason for that is there's a title function in base R. Didn't want to overwrite it, so made ggtitle. You have the option for subtitles. I tend to not use subtitles or titles in my plots because almost always when I'm publishing it, the title of the figure is in the text and not over top of the plot. But you can still make it, especially if you want that for some reason. I almost never use subtitles for plots. But again, there are arguments to do that, and we're just printing it out. Now, again, I still think this is an okay plot. I hate that the legend's not on there, but there are some slides that I'll get to on how to make that a little bit better. So again, we've saved this object, Q, right? So now, if I say PNG, I'm opening up a device. I'm opening up a PNG with the defaults in there, whatever resolution, height, width it's got in there, and then I'm printing out Q, right? So I'm printing, right, like you normally would, just putting in Q. I'm printing it out so that the output is actually saved in that device, and then I'm turning off the device. And you will see, depending on if you're on Windows or Mac or whatever, it's just going to say some device that you're on now. There is, when you're like working in R, there's like some default device that you're going to. That's that little thing in the corner. When you say dev.off, it says like, okay, that device is over. I've saved that plot. And all I'm showing here is there is a bunch of file accessors in R that say file.exists, and we see that it's true. Which all I'm saying is this slide is not a lie. We actually wrote something out. The file exists. All right, themes. So you want to change a lot of the aspects of your plot. The theme function is the way to get really those internals. We're going to talk about that. But there are some really great default themes that are out there. Theme_BW stands for black and white theme. Like you want to take away those gray grid lines, all that kind of stuff. There are a whole bunch of themes throughout R. If right now, type in $theme BW, and you will see a whole bunch of different themes in your data that you have access to. Theme gray, BW, line draw, light, dark, minimal, classic, void. The void theme. I've never used that, but you know, it just makes you depressed. Anyway, so the theme function itself, though. So those are specific themes that set defaults for your data, but on top of that, you can still add other things with the theme function. So the theme function has a whole bunch of arguments. Text is the overall text of the entire document, or the entire figure. So it is a little bit convoluted in my opinion, but it's really understandable when you come from the perspective of ggplot2. So the idea is text. What are some aspects of text you change? You change the color, you change the size, you change the font type, bold, italicized, all that kind of stuff. That is why in ggplot2, when you're changing things about the text, the overall text of the figure, why you need another function to help you out. That is why. So the way you change that is for every text argument, you say this is equal to an element_text. That is another function in ggplot2. And in this case, we're changing the size to 12. But for the title, we're changing the size to 20. So it allows you to change things independently of each other or globally. Text is all the text in all the parts of the document. Title is for wherever you see a title. That's the labels and the labels of the figure, labels of the legend. Now, again, there are other arguments here. You change italicize, all that kind of stuff. That is why you need these helper functions to change those defaults. Because I've gotten a lot of discussion points where it's like, why isn't it just like when I say theme text equals 5, it knows that like the size of the text should be 5. It's like because there's a lot of aspects of text you can change, right? So you need this additional function, and in order to not have like 500 arguments of this function, like text.size, text.font, text. Bold. That is why you have these additional helper functions. So here is an example of changing a lot of different things. So there's axis.text. You can change the element size to 14. Here we're making the titles to be 20 by default, but just the axes, we're going to make them a little bit smaller of 0.96. Here the legend position, where it gives it in the position of the legend
with respect to percentages of the figure. I'm saying I want it to be 90% in the x-axis and 80% on the y-axis. Now the legend is actually inside the plot. So if you look at this on your machine versus here, you'll see that there's a big white box around there. I'll show you how to get rid of that. And then on the top of it, we add on, again, we're using the guides function. The colors is the thing we map to, and then we have to tell, just like we did with text, we have to have a helper function that talks about the legend a bit. We have a function called guide_legend, which has a whole bunch of arguments. How big do you want it? Where do you want it? You know, what other information do you want? Do you want everything to be italicized? Do you want the text to be a different size? And one of those arguments is the title, so that it allows you to change the title of the legend, right? Because a lot of times you might be plotting a variable that's not really such a nice name, such as country, or you just want to make this capitalized. That is one way to do it. Yes?
But in the other one, by default, it's gonna pull it in just based off of it being a legend. You didn't have to call it out over here.
Call it out.
Call the legend out in any way.
Nope, it just makes the legend. It says like it's going to use the variable name as the title, no matter what that variable name is. Here we're
Because you moved it or because you wanted to rename it?
this is for the renaming.
Okay.
This is for the moving.
Right.
Okay. So the theme we moved it. The guides we changed some of it. So there's a function I guess a object that I kind of create a lot. It's called transparent_legend. It makes pretty much a legend transparent. This is not in ggplot 2. This is something like that you have to define yourself that I've created. So it's just pretty much saying like if you put it inside the plot, if there's any data behind there, you'll be able to see it, even if the legend's overlapping it. But if in the slides, this makes a lot more sense because this and this don't look much different. But on the actual slides themselves, you see this white box that actually obfuscates everything in the background. So we're going to go to the lab once I'm done all this. So again, if you put in just X into ggplot, right, you'll get a histogram. You can change that by the number of bins or bin width like we talked about. So there's two different arguments to define like a histogram, the number of bins or the width of the bins, right? But again, if you just put one variable in there, you're going to get a histogram. Just like we did with the other data with respect to coloring things differently. We can fill things differently in a histogram. So here we are filling the insides of these square rectangles with what country it is. So and by default it stacks everything onto each other so you can kind of see the overall mortality rates over all time for these countries. There's a so let's skip that. So here, ggplot, we're doing the same thing, but instead of doing histograms, we're doing densities, right? So we're doing some smooth densities, but again, it's going to be filled, the polygon's going to be filled with what country it is, and here we're saying alpha equals 0.7. So again, that's the opacity, so that allows us to kind of see through the different densities. Otherwise, it would just be one blob here, kind of like we have here. Right, it's not very helpful, especially if things are overlapping. But if here we put the opacity down a bit, so you can actually see through them. And then here I didn't want it to show any legend for the alpha like it would on here. I don't really want that, so it just says get rid of it. There is a way you can change the density here. Just to be clear, we said fill equals country. Here we're saying color equals country. The difference is the fill will change the color inside of here. Keep them all black lines. Here, the lines will be colored differently for each country. I think this is a pretty helpful plot. I don't like seeing like the overlap, things like that. I think this is a good way to visualize distributions. This is just another way of doing that same plot. I tend to hate these lines that go down and over. This is just a different way to do it. Again, nothing that is going to be take-home message that we shouldn't move on to statistics for. Geom tile, I don't use as much. There are heat map functions that are probably a lot better than this. Like pheatmap is a package that's really good, but you can do heat maps in in ggplot 2. Again, we've talked about Color Brewer. There's a package called R Color Brewer, which allows you to have a lot of different types of palettes for diverging and sequential data. Again, so like if you have something that goes from low to high, you might want to change the palette using one of these brewer palettes. So if you say brewer.pal,
It talks about the different types of palettes out there. We've visualized that on the website, colorbrewer2.org. There are some other examples of how to make bar plots and how to make different bar plots for that are like proportion tables, things like that. We show like the vehicle age, which these is a proportion. I don't make these as commonly, but a lot of people do. I would go over them at your own kind of behest because I don't know if these are that useful. Some people think they are. I'm not really sure. I think a table's generally pretty fine with these, but some people really like stacked bar charts, so we put them in there. Yeah, so this is kind of more of the same. Again, spaghetti plots, same thing. You can factor just making things by color. So things like this. See, this is a reason why like you definitely need to know how to use guides and turn them off. Because sometimes you just want to see the trajectories, not necessarily be able to pinpoint every single one of them. But again, using really complicated coloring along with facets can allow you to see things a lot clearer. Again, we could turn that guide off if we want. But facets really combine things very, very well. Again, turns the guide off. And then I think that's for the most part, other than showing you really terrible plots like that. Like that's one of the reasons why we subset the data to be those subset of countries, because without any faceting, without anything like that, you just say to be color, you'll get like really just a hodgepodge of spaghetti. All in those plots. So let's move on to the lab. We're going to probably take probably around 10 or 15 minutes on that to go over them. The reason is I know we try to spend as much time as we can in the labs, but in order to cover all the material, we're going to have to jump into statistics around like 11. So again, there are tremendous resources online for like ggplot2. Like, maybe not getting you exactly what you want, but like I want to do this plot with like this thing and this thing. There's like a lot of like answers on Stack Overflow that are just like, here's exactly how you do it. The other thing is, I didn't really touch on it per se when I did those stack bar plots, but there are many times I would say that sometimes you might not be able to get the exact plot you want in ggplot, but you can get it much easier by doing data manipulations. Right, so doing actually summarizations and data manipulations yourself versus trying to rely on ggplot to do those summaries for you, it can become a much more powerful combination using the tools you know in dplyr. For example, here we made a table of whether the data is a bed buy or vehicle age and got like counts, got a count table, and then turned it into percentages by dividing by the sums of those. So I created my own my proportion table and then I plotted it versus trying to rely on my ggplot2 skills and saying like, oh, I want you to divide by the sum for each one of these factors and try not to make ggplot2 do as much guessing, as much work, but actually doing the work on the back end using dplyr. Okay? All right, let's jump to the lab and we'll float around, and then Andrew will move on to statistics. Yeah. I'll be honest. Okay. Okay.
And I don't know if we can ever like scale color argument because this one ran by the links and then this one
Color you don't like.
seriously.
That's how to fix it.
Okay.
So try that.
From T0, but I was wondering, is there like a look command, like instead of jitter
Yep.
parentheses
So,
3,
So what are we saying? So we're saying, all right, we're going to get the X of that deal, A's, Y's, going to be the number, and everything's going to be called about the line. Great. Now, here, we just told it, you know what?
So we're taking through that. Just gave me
So, in there we have to say, there's another assignment group. We say like, the group is questions. So then, this is line.
So we'll take, run that.
Say, yeah.
And that should be good. But let's run that again in a minute. But take out. So that's what we're saying. Let's take out the color data.
So it's integers, okay. And then, the other question was
No,
that.
it's not just integers. I'm saying it's not anything.
You should be able to up them.
Oh.
That's what I'm saying.
There's still less than that, though. Still groups. But the, but
But we're saying just a group and then use this scale format, we're not saying.
Like,
Right,
I
still,
wanted
it's
to put on
geoms.
upper right corner,
inheriting from
and then like, oh, what if I went on the
Actually,
right?
Yeah, you can set it.
Yeah.
So that's what you understand. So that kind of, even though you didn't say anything about color, right? It said it already inherited that. So that's fine.
Several years ago.
Yeah.
I did.
And then I set it to, you can give it,
I just like had it
Oh,
tell it to be
arranged
1,000.
differently.
So I see these coordinates 0.8, 0.9, so are those like inches?
Then it would be.
No, those are like the
color afterwards, I don't use the scale.
Ah.
values. So
Uh,
the first one of it, for x axis,
Uh-huh.
second one is y.
I mean,
No. So because, so the scale column
And then
just
scales, so
resets
x
the
axis
colors
goes
to be
from 0 to 1.
what you want.
So that's what the value is.
It doesn't
And then to get to
change the fact that you originally set the color
the
color.
position was,
Okay.
and the scale of 0 to 1.
So that geom smooth will still stay like that. Although you set on something like that,
Yeah.
right? So it's still gonna inherit
And
the
the
problem.
value.
But it'll just use the default, it just won't use an actual scale.
So the scale, so although the order doesn't just one flash
Oh, really?
So like so try that. Try
Yeah.
that. So you just scroll over there. You just scroll down. So like I'm saying like let's just try. Yeah.
So if it's 0 and 100, I still put.
Yeah, just like how.
0.8, 0.9.
Yeah, it's still there.
So
It's
it's kind
still
of
there in
like,
the background. You just don't see
I
it.
want
It's
it
bottom
like 90%
first.
to the
Yeah, but then you
Yeah,
also see
but like if you took out.
We took out the points.
You can do that?
Yeah.
And it would know that I wanted 80%.
No, it is not that easy. So
Okay.
today is the actual
Got
value.
it.
You
So
can
I still
yeah.
know
You
that
can use the actual
The only
values
way
or
you
you can use
Yeah,
the
exactly, yeah.
overriding
are
is
doing like.
inside.
It depends on how it is.
Okay.
So that if you're.
Yeah.
It's a little bit
You're using a percentage.
So I agree that so there's a couple ways you know. You
Yeah.
do like the grouping it's like in like a plotable thing. Like
Or you just do it in
Yeah.
each individual.
individual genomes.
If you did
I
that,
didn't even have to do
You can do that separately. So but the thing is you can.
Oh, so if it's within the range of the data, then you should put the data.
Okay, so you can only do that for JHSPH.
Well, I guess
And
it's
then
I
you
should
should
just
put
exit.
upper
No,
corner,
no, no.
upper
So
left corner,
if
upper
you do
right corner.
So, no,
Bottom right
actually,
corner,
it's,
upper left corner, up, down.
Yeah.
Because they don't like legend,
Yeah.
they won't scroll. But like, oh, here we go, the legend is over here, right?
Yeah.
So like, technically,
Right, so
this
if I say
legend is here,
long,
here. So like, drag it over here, and I take it like 0.8, 0.9. Coordinates, is the box gonna start here?
Oh, that's
Or
a
like,
good point. I'm not sure.
I
think it's set as there.
okay.
Yeah, and also it drags the whole thing, and then,
So I do that.
You can also
Then-
change the alignment. Like, this is
And then we
basically- you can make it horizontal.
Cool. How?
It's also here, it's legend direction.
Actually, shouldn't put it.
Ah, okay.
Right.
And then,
Then I can say genome
the other
smooth,
question, yeah.
but it's not it's still gonna be
This word,
more
like,
smooth.
Definitely.
So
You can do legend direction. You can have correct legend ones, because like there's so much you can play.
Oh,
So you can just do that.
There's no one good way as well, so there's like no
But again, it's
project
that
that
will
changes the best desktop.
if you want to relax.
Don't try that. That's
Because
just
it's smoother, but you
someone else predicts you have to change the couple of iterations just to show
and then you can, so I'm saying you can do it.
Because you have a lot of different ways, yeah.
You do it a lot of different ways, and sorry,
And then once you find out what you're doing,
to see the thing about this is though, inherent. I think it's
Thank you.
Then it would give you the blue.
so because ggplot in the background, ggplot, ggplot, is that like ggplot? Ggplot is just like a
Yeah, and this doesn't have the compass, it's going forward, so.
Well, this says you can guess what that's what she wants. Right? So, right, you said you put two things in this, I'm guessing. Whereas if I did ggplot and then I added the points, so all I'm saying is in ggplot, you start with one canvas and then add to it. In qplot, you try to guess.
Yeah.
But in you can't get ggplot to the guess. Or you can't get the ggplot function to guess, and you can't get qplot to not guess.
Okay.
We're gonna come together.
Yeah, so if you wanna be really explicit, then you should put ggplot,
Yes.
or if you just wanna like get like the ggplot. Okay.
Because like, but now it's nice because like you make like maybe just an X and Y that fix. So you have like the layer here for this spot, the layer here for this spot, and there's like two separate plots. Whereas in qplot you have to like two.
Yeah.
You could just be like G plus this, G plus that.
Okay, alright, thank you.
I guess we don't get to like Arnold and Pinot and all that stuff at the end. It's like 5 steps.
Yeah.
Visual.
All right, so I'm going to just go briefly through some of these really quickly. I know we've rushed through this lecture a bit, but again, we really want you to get to statistics. And a lot of these are not that extravagant of a jump from what we've talked about in the lecture and what we've already done. So again, facets or facet wrap. Again, you can do a qplot where the date is the x-axis, the y is the number of riders, and then the date is the average. You can just say tilde line. Again, this tilde might seem a little bit strange, but when you think of it, what Andrew's going to talk about in a minute from models, it is the data is a function of. That's what the tilde kind of means, right? So when we define a linear model, y is a function of x. And if you think of it that way, then just doing like line, like plus x2 plus x3 makes sense. From a modeling perspective, the data is a function of blank per blank per blank, which will do separate panels for those combinations. So again, it'll give you different panels for the different lines. And again, you could have also done explicitly facet underscore wrap. Lastly, if you type in facet, there is another function called facet dot underscore grid, which will allow you to do grids of the data, which is a little bit different than facet wrap. But explore that on your own. Again, lastly, all this function does is allow us to set the color palette of the things we want so that they're explicitly like blue, green, orange, and purple. But again, once we've already made the data faceted by each line separately, you don't necessarily need to color them again. So plot the average ridership by date with separate panels by day of the week colored by line. Now we have lines being colored, the palette being exactly what we want it to be, but now we're seeing that on the different days of the week. So lastly, I will show you, I'm not going to color the data anymore. This is the only example I think we're going to give where we show you can have multiple facets. Problem with that is it's going to do all the combinations. So every Monday, banner, Tuesday, right? So some of those facets can get really large in number very quickly. So I'll wait for a sec. So for example, that is all the facets of Thursday, banner, Wednesday, all that kind of stuff, right? So that allows, that's two variables that do all the combinations of the facets. So here we're taking that original first plot, average ridership by day, color by line, and then we're just changing things about the x-axis, the y-axis. We're adding it to be a black and white theme, and we're saying the size of the text should be 20. So we'll just see what that kind of gives us out, and at the end of the day, nothing. No. Sometimes when this shouldn't happen really on your machine, but the fact is on mine, I'm like very zoomed in, and sometimes the size of the plot, sometimes the plots don't come up on the right hand side. You see we get really, really big sizes of the text, and then also we have black and white lines. So here we're just going to look at the orange line. So again, we're going to use filter, and then we are going to create a line, and we're going to explicitly, right, this is outside of the AES function, we are going to say that the line type is dashed, but we want the color to be orange. So this is a just ugly plot of the ridership for the orange line, where we actually did a dashed line. We could have just, so by default it'll just give you a solid line. We just did a dashed line here, right? Again, we could have done the same thing with the ggplot command versus, so I think this is the exact same function. Ah! Why is it so ugly? Don't do this. If you're setting something globally, do not put, so this means something totally different than the thing above. So when you're saying color equals orange outside AES and color equals orange inside of AES mean totally different things. This is essentially, again, trying to define a new variable and then coloring it by that variable. But that variable is only one value, so it goes back to the default palette. So also, inside the AES, do not use quotes. Inside AES, use the variable names themselves. Okay. And then there's just other options to show you how to do it with qplot. All right. So I know that's like a quick foray into ggplot, but the idea is